Dear Euclidean learners, welcome to our mathematics lesson. I am Euclidean, and this lesson is proudly brought to you by the Gauteng Department of Education. I really hope you are ready for our lesson, Cretans. We'll try to move a bit slowly today. I know last week there was too much to do in the lesson and some people felt like they were being left behind. Let's try to move together. Please let me know if I'm moving fast. Use 063. Sorry, let me say the number again. 063 to what is happening? 063 629 3655. 063 629 3655. I got it right now. Okay, right. We are going to look at the midpoint theorem. We're going to look at the midpoint theorem. Remember, this is under Euclidean geometry. So we're going to use also some things we have learned under Euclidean geometry. Do you remember the things? Geometry of parallel lines, geometry of lines intersecting in parallel, and also geometry of triangles. Okay, and then we're going to deal with the midpoint theorem. So at the end of the lesson, learners, you should be able to investigate the line segment. That's the main purpose of this lesson. We're investigating the line segment joining the midpoint of two sides of a triangle. How many sides of a triangle? How many sides does a triangle have? It is a 3 sides, isn't it? So now we have this line segment which is joining the two sides of a triangle. What is its relationship with the other side? Remember, a triangle has 3 sides. Midpoint to 2 sides, and then what's the relationship of this line to the other side, the 3rd side? That's what we're going to learn today, right? And then we're going to prove the midpoint theorem. At the end, the last part of our lesson, we're going to prove the midpoint theorem. And then we're going to apply the converse of the midpoint theorem. That's what we are going to do in today's lesson. Let's be ready for our lesson, grade 10s. Make sure you have your pencil, your ruler. We're going to draw triangles. We're going to draw lines. Make sure you have those things with you. Okay? Right. And in grade 8, grade 9, even grade 10, we have done some of these things. We have done geometry of straight lines. We did revision. That was our first lesson. And then we did geometry of triangles. That was our second lesson. Okay, even in class you have done this. And then we have done the properties of quadrilaterals. The previous lesson we looked at the properties of quadrilaterals. Do you remember? We're going to use these in today's lesson. Also, we have the Pythagoras theorem. Okay, right. Now let's have our short activity, just the baseline activity for 5 minutes. Answer A, fill in the gaps. AD is equal to what? What's the reason? Remember Euclidean geometry. Statement, reason. Statement, reason. EC is equal to which side or which line segment, and then give the reason. And then find the angles marked X, Y, and Z in 5 minutes. Let's try. Right, welcome back, Cretans. Was it difficult? Let's mark our work. Cretans. Right, 80. This is 80. What does this mean? It means the two lines are, or the two line segments are equal. AD is equal to BD, and also the symbol here, it shows that AE is equal to EC. So we're given that. So we can say AD is equal to BD is given. Please mark that. The reason must be there. And then AE is equal to EC is given. See that? Okay. And then now let's find our angles. Let's start by finding angle X. Right, if you check, this is a triangle ABC. And then angles of a triangle add up to 180 degrees. So if we say angle A plus angle B plus angle C, we must get 180 degrees. And then there is angle sum in triangle, or you can say interior angles of a triangle is still fine. Okay, and then angle A is 40 degrees, angle B is 82 degrees. You can substitute there, and then we solve for X. Angle C is X, so we can solve for X there. And then angle C, we subtract 122 from both sides of the equation, and then we get that angle C is 58 degrees. So this is 58 degrees. Okay, mark that. Do you have your statement and reason and your answer? Okay, all right. Now we need to find angle Z and angle Y. It's now easy. Let's start by finding angle Z. Angle Z is equal to angle B is equal to angle ADE. These two angles are equal. Why are they equal? Angle Z and angle 82, they are equal. Why? They are corresponding angles. Do you see that? They are corresponding angles. So angle Z is equal to 82 because corresponding angles. DE is parallel to BC. And then what about Y? What is the size of angle Y? It's going to be, which is 58 degrees, because these two angles are equal. You see that? They are corresponding angles there. So angle Y is equal to 58 degrees. Did you get everything right? We've revised some of things. Very good. Now we need to learn about the midpoint theorem. Let's go there. Right, midpoint theorem. I'm going to start by giving you a preview. Okay, just to show you what we're going to do, because we're going to do an investigation. I don't want you to see now rulers starting to fly in here and saying what is happening. Let me just tell you what we're going to do, and then we'll do it nicely together. Okay, so remember, we are investigating a line segment. Please don't write anything for now. I'll tell you when we start doing our investigation. I'll give you time to write. Now just listen as I give you the preview. We're going to investigate a line segment joining the midpoint of two sides of a triangle. So we're going to have our triangle. You will draw your triangle later. So we're going to measure the size of the triangle. We're doing an investigation, and then like this one is 14 centimeters. We measure the size. We find that is 14 centimeters. We measure the size, and then find that one is 12 centimeters. That's what we're going to do. But remember, it's not about an isosceles triangle only. It's by coincidence that here I have an isosceles triangle. It can be any triangle. Scalene, right angle triangle. What we're doing now, it can be for any triangle. Right. So we're going to do all those measurements, and then after doing that, we're going to mark the midpoints. We're going to use midpoints of two sides, AB and AC. So we'll mark the midpoint of AB, and then after marking the midpoint of AB, we name it D, and then we mark the midpoint of AC. You see that? And then we name it E. That's what we're going to do. Remember, we're investigating a line segment joining midpoint of two sides. Do you see that? And then we're going to draw a line, DE. You see, we have the line segment DE, which is joining the midpoints of two sides. the midpoint of AB and the midpoint of AC. We want to see the property of this line segment in relation to BC. You see, we have the midpoint of AB, we have the midpoint of AC, and then the line that we form, DE, how is it related to BC? That's what we want to find out. Okay, are you ready now? Make sure you have your ruler and your pencil. Please follow my instructions so that we can learn from this investigation. Right. Investigate the line joining midpoints of two sides of a triangle. Draw triangle ABC as shown below. Please draw your triangle, which is almost similar to this, but not necessarily the same triangle with the same measurement. I will give you the measurements. Let's say if our side is 14 centimeters, it does not mean that your triangle must be 14 centimeters. Just draw your own triangle that can fit in the space that we have. But when you are writing, you write the measurements that I'm going to give you. Okay? Because if it says that measuring, it can take a lot of our time and we won't finish the lesson. Just draw any triangle which is almost the same as this one, and then I'll give you the measurements. Even if your triangle is not 14, 14, 12, it's still fine. Just draw any triangle. Let's do that for 1 minute, then we continue. Right, welcome back, grade 10. This is a very, very important activity because you will see what we're going to say is our theorem. You will see it, we're going to investigate, and you'll discover the theorem, and you mustn't forget it. Right, let's start measuring at the sides of our triangle. So we have this side, we're going to measure and name the side. So it's side BC, please name your triangle. You will name as or fill in the information as we move on. So the side there, BC, how many centimeters? My ruler, I hope my ruler there is clear. It should be 14 centimeters. Do you see that from the ruler? So write 14 centimeters there. BC is 14 centimeters. BC is 14 centimeters. So you have your BC and 14 centimeters. Even though your side may not be 14 centimeters, just write 14 centimeters. Let's measure this side. AB, again, is 14 centimeters. Like I said, it can be any triangle. It does not mean that the two sides must be equal. No, it can be scalene, it can be obtuse, scalene, it can be right angle triangle, any triangle. Again, that is 14 centimeters. Name the vertex A and write 14 centimeters. Remember to let me know if I'm moving fast. 063 629 3655. Any input that will assist us in our lesson, please send that input. Let's measure AC. Okay, right, you see it's 12 centimeters. 12 centimeters. Let's write 12 centimeters AC. We're doing this investigation so that you can see, so that when I tell you that the line segment joining the midpoints of two sides of a triangle is this, you see, yes, it is, because I saw it. Okay, it's very important that we do this investigation. Right, now let's mark the midpoints of two sides. We're investigating the line joining midpoints of two sides of a triangle. Remember that. And we're using AB and AC. You can use any. You can even choose to use AC and BC. But now we don't have time to do all the sides. We'll just do one pair, AB and AC. Let's mark the midpoint of AB. AB is 14, so the midpoint should be at 7 there. So we mark that 0.7, and then that's midpoint of AB. Name it D. Let's do that. Just put a dot and name that dot D along AB. And then let's find the midpoint of AC. That's the midpoint of AC. AC is 12, so the midpoint should be at 6. So mark that point and name it E. Okay, have you done that? Okay, right. You don't need to measure your things. I'm going to give you the measurements. You just write. Right, now let's join our points, midpoints, to have our line segment DE. Right, now we have our line segment. We're investigating a line segment joining the midpoints of two sides of a triangle. Our line segment that we're referring to in this case is DE, line segment DE. Okay, right, let's measure DE. We measure DE. Do you see the measurement there? What is the length of DE? It is 7 centimeters. What can you say? What is the relationship, or in relation to BC, what can you say about DE? In relation to BC, what can you say about DE? Let me give you 1 minute to discuss. 1 minute, then we continue. Right, welcome back, Cretans. What did you discover? I hope you discussed. What did you say? BC is what? 14 centimeters. DE is 7. Do you see that DE is half of BC? So we can say BE is 2 times DE. It's a theorem. Once you're saying theorem is something that has been proved, you don't need to say anything. Once you see a line segment that is joining two sides of a triangle, then that line segment is half of the third side. You don't need to do any measurement. Just use the theorem. So now BC is 2 times DE, or you can say DE is half times BC. We have proved that now. So when I give you a triangle next time, and I say this is a triangle, let me draw like this. I say this is midpoint. It's a P, Q, R. I say this is the midpoint M. This is the midpoint of PRN. And then if I say this is 2 centimeters, and then I ask you, what is the length of QR? You don't need to take your rulers and start measuring. Use the theorem. QR is 4 centimeters. What's the reason? Midpoint theorem. Okay, 1 point. We have done 1 point on the midpoint theorem. There are two things. One more, and then we look at the application questions, which are very, very easy. Okay, let's go to the next part. Right, now what can you say from this? A line segment joining two sides of a triangle is half the size of the length of the third side. Or is half the length. If I say size and length is just one thing. It's half the length of the third side. Line segment joining the midpoints of two sides of a triangle is half the length of the third side. One more thing about this line segment with the third side. Let's check. Right. Now we're going to draw or measure the perpendicular distance between these two lines, DE and BC. Let's measure the perpendicular distance. Put the ruler there. What is that? Between 5 and 6, that is 5,5. Do you see that? That is 5,5. Let's write it down. Please draw your perpendicular distance, height, and then write 5,5 centimeters. Let's do that. On the same diagram, don't draw a new triangle. We do the same thing on E. Right. And then again, you see that? It's also 5,5. Do you see that? So what can you say? 5,5, write that one down. I will give you 1 minute again for you to discuss with your colleague. Right, you can discuss, 2 of you or 3 of you, discuss what do you observe now. What can you say from this distance 5,5, okay, from BC to DE? What can you say? 1 minute. Welcome back, returns. What did you discuss? These lines are equidistant from each other. The perpendicular distance between them is equal, like the railway line. We talked about that when you're looking at the geometry of straight lines. What type of lines are those? Those are parallel lines. So it means the line segment joining two sides of a triangle is parallel to the third side. You see that? So we've talked about two things, the length and this property of being parallel. So let's combine these two and come up with our theorem. The line segment joining the midpoint of two sides of a triangle is parallel to the third side and equal to half this length of the third side. That's the midpoint theorem. Okay, let's write it down. I'll give you 1 minute to write it down. Here it is. Oh, sorry, I forgot this. This is the symbol for parallel. Okay, you can write that. DE is parallel to BC. That's what we found out. And then let's write our definition. What do we say? Remember the theorem. What are we talking about? And then what does that thing we're talking about do? So we're talking about what? We're talking about the line segment joining the midpoints of two sides of a triangle. That's what we're talking about. Then what does it do? It what? You can say this line segment is parallel to the third side and equal to half the length of the third side. We proved the brown part and the red part. So this is the complete what? Midpoint theorem. Let me give you the acceptable way of writing the reason so that I give you 1 minute to write everything. So we're saying that in this case, DE is parallel to BC and DE is half of BC. And then the acceptable reason, you just write midpoint theorem like that. Okay? Let me give you 2 minutes to write this. You must have this theorem, write it down for 2 minutes. Okay, I hope you managed to write your notes. I want us to discuss about the converse theorem for the midpoint theorem. What is the converse theorem of a theorem? Let me give you a simpler example before I come back to the midpoint theorem. Right. If I have parallel lines, AB and CD, these are parallel lines. We're given that they are parallel, isn't it? And then I have my transversal. What can you say about this angle and this angle? Let me name them: A, B, C, D, E, E1, EF1. What can you say about E1 and F1? They are equal, isn't it? Because the lines these are alternate angles, because line AB is parallel to CD. They are equal because they are alternate angles, because these lines are parallel. But let's say I give you this, the line AB and the line CD, and then I say angle E1 is equal to angle F1. Are the lines AB parallel? Is line AB parallel to CD? Yes, they are parallel because the alternate angles are equal. You see that? That's the converse, like the other way around. We said the alternate angles are equal because the lines are parallel. Now here we're saying the lines are parallel because the alternate angles are equal. So this is the theorem, this is the converse. I'm just using this as an example. So it's the same thing with the midpoint theorem. So the converse theorem. Now, check the diagram here. We have line segment DE, which is from the midpoint. D is the midpoint because you can see that AD is equal to DB. So D is the midpoint. We have the line segment DE, which is parallel to BC. You see that? In the theorem, with line segment DE joining the midpoints, and then we found that they were parallel. Now we're told that the line segment from the midpoint parallel to BC. Then what does it do? That's the midpoint theorem now. You see that? So now the line segment DE drawn from the midpoint of one side of the triangle parallel to the second side. Then what does it do? Let's check that. So the line drawn from the midpoint of one side of the triangle parallel to another side. The line drawn from the midpoint of one side of the triangle parallel to another side. What does that line do? It bisects the third side. It bisects the third side. Which third side are we referring to here? The side the side AC. The side AC. It is bisected. Remember we talked about bisecting in the previous lesson. When a line segment is bisected, it is divided into two equal parts. When an angle is bisected, it is divided into two equal parts. If you bisect a 60-degree angle, it's going to have 30-30. If you bisect a line segment which is 10 centimeters, it's going to be 5 centimeters, 5 centimeters. So, a line drawn from the midpoint of one side of a triangle parallel to another side will bisect the third side, meaning that AE is equal to EC. That's the converse theorem. And then you can write your reason, and then line through midpoint parallel to second side, or just write converse, and then midpoint theorem. This one is easy to remember. Converse midpoint theorem. Done. Let me give you just one minute. Will it be enough? Let me give you 2 minutes. 2 minutes, and then we'll continue after that. Right, welcome back, grade 10. Now it's time for us to use what we have learned. It's time for activities. I'll give you time to try, and then after that we mark our work and discuss, isn't it? I think that's fair. Just look at the first one. It's an example. I said an example, but it is an activity. Consider triangle KLM and that P and Q are midpoints. It's giving you, please read the information, grade 10s. Don't just look at the diagram and start answering questions, no? You'll find Euclidean geometry very, very difficult to deal with if you do that. You read the information. The hints or the clues come from the information. Triangle KLM and that P and Q are midpoints. You see that? It gives you a clue. P and Q are midpoints. This should be midpoint theorem. You see that? And then KL and of KL and KM respectively. Right. PQ is parallel to what? Fill in that. PQ is equal to what? Times KM. And then KM is what? Times PQ. I think you'll need 1 minute for this. Let's try. Welcome back, grade 10s. You must get everything correct here, isn't it? Remember WhatsApp line, grade 10s, 063-629-3655. Let's engage each other. Please, grade 10s, let's communicate. Right, no one should be left behind. PQ is parallel to what? PQ is parallel to what? Let's mark our work. KM, raise your hand if you got it right. Raise your hand in class there. Okay, good. Right, PQ is equal to what times KM? PQ is half of means times. So PQ is half of KM. How many got it right? Raise your hand. Good. And then KM. KM is 2 times PQ. KM is 2 times PQ. Mark that. Perfect. Excellent. Right. Should we move on to the next one? Let's check the next one. It's not difficult. This one you will need 5 minutes. You'll need 5 minutes. Consider triangle KLM and then that P and Q are midpoints of KL and KM respectively. If PQ is 7 centimeters, angle L is 62 degrees, and angle M is 45 degrees. Determine with reasons the length of KM with reasons. Let's go back. No. I made a serious mistake. I think we're marking wrong things there. We forgot reasons. Very important. We can't leave out reasons. Right. So the reason here, midpoint theorem. Okay, right, sorry for that. And then you be the same reason there. Please write it in full. Don't write like me like this. Okay, same reason there. Midpoint theorem, midpoint theorem. Every time, statement and reason. Right, we're doing this one. I read the information. So determine with reasons the length of KM, the magnitude of angle K, and then the magnitude of angle Q2. Let's do this in 5 minutes. Let's try. Right, welcome back, grade 10. Let's see the length of km. We're marking our work now, please mark in pencil. Right, the length of km, PQ is 7 centimeters. So what is km? Km is going to be, it is 2 times PQ, so it means it's 14 centimeters. You see, we have a statement and the reason. Even if you have this and the reason is still fine. Okay, you can have this and your reason is still okay. Okay, so km is 14 centimeters. Then angle K, this is almost similar to what we did in the baseline. So we have these three angles of a triangle. Angle K plus angle M plus angle L. You see that? They add up to 180 degrees. These are angles in a triangle. So it's angle sum in triangle. Angle sum in triangle or interior angles of a triangle is still fine. Here's the reason. And then we substitute and solve for K. Right, let's subtract 180 minus 107 because these two will give us 107. We get 73 degrees. So angle K is 73 degrees. Please mark that. Okay, right. And then the next question, we're finding angle Q2. What did you do? We can do it differently. But I'll show you what I did here. We're saying that PQ is parallel to KM anyway. Why is PQ parallel to KM? Because of the midpoint theorem. PQ is parallel to KM, midpoint theorem. So PQ and KM are parallel lines. So 45 degrees and Q2, what type of angles are these ones? Same side of the transversal between the parallel lines. What do we call them? They are co-interior angles. They add up to 180 degrees. So M plus Q2 is 180 degrees, co-interior angles. Okay, and then we substitute and solve for Q2. So here we're going to subtract 45 degrees from both sides of the equation. We get that Q2 is 135 degrees. Okay, the other way, now I've used same symbol as if these two angles are equal. They are not equal. Right, 45 and Q1 are equal. Do you see that? Because there are corresponding angles. So we can say this one is 45 degrees. And then you can use adjacent angles on a straight line to find Q2. It's still okay. So adjacent angles on a straight line, say 180 minus 45 degrees, you still find Q2. Okay, right. And then the last question, I'm going to give you 5 minutes. Right, AC equals 30 units and DE is equal to, so let me read again. AC equals 30 units and D and E are midpoints of AB and BC respectively. Right, prove that triangle BDE is similar. Sometimes we have a problem with these two signs. This is for congruency. This is for similarity. Remember that. Okay, we talked about this in our lesson. Similarity. It's like you're taking these similarity. How do you spell similarity? It's like you're taking these, and this and forming this. That's similarity. The other one's for congruence. Now determine the length of DE, give reasons. Let's try to do these two in 5 minutes. Remember the condition for similarity must be the corresponding angles are equal. Angle, or the corresponding sides are proportional. Okay, let's try to do that. 5 minutes. Right, welcome back, grade 10. Let's answer, let's mark our work. I think B was easier than A. Do you see that? Determine the length of DE. So DE is what? 15 units because of the midpoint theorem. Do you see that? Right. Okay. And then, but now let's do from A. It's fine. Right. We need to prove that triangle BDE is similar to triangle ABC. Let's highlight the triangles that we're talking about. So there's triangle BDE. So I'll use the color coding here. Green for triangle BDE and then red for triangle BAC. Right. So BDE, this is the triangle BDE. And then we have triangle ABC, which is this one. Are these two triangles similar? Right, let's check. Are the corresponding angles equal? Right, so we have DE is parallel to AC because of the midpoint theorem. So now, you see that midpoint theorem there. Now, these DE and AC are parallel. Then now we can talk of the angles. Angle D1 and angle A. Do you see this? Those are corresponding angles. And then angle E1 and angle C. Those are corresponding angles. And then we have a common angle here, which is B. So we have the first one, B, which is the common angle. So it means B for angle, B for the green triangle is equal to B for the red triangle. It's a common angle. Right. And then we have D1 is equal to A. D1 is equal to angle A. Their corresponding angles. DE is parallel to AC. We found that from the midpoint theorem. And then angle E1 is equal to angle C. Again, corresponding angles. Because DE is parallel to AC from the midpoint theorem. Do you see that? So now the corresponding angles are equal. Angle B is equal to angle B. Angle D1 is equal to angle A. Angle E1 is equal to angle C. Therefore, triangle BDE is similar to triangle BAC because of angle, angle, angle. Be careful even with the vertices. B goes with B. So that's why we have B, the first position here, and B, the second position here. Then D goes with A. That's why you have D there and A there. And then E goes with C. That's why you have E there and C there. Do you see that? Okay. So we proved that. We have applied midpoint theorem. Do you see that? Okay. Right. And then determine the length of DE. We say DE is half of AC. Midpoint theorem. Midpoint theorem. So it means DE is 15 units. Right. Let's take a short break, grade 10s, and then when we come back, I'll just show you the homework, and then after the homework, we summarize our lesson. Let's take a short break.
The road to success, to becoming a successful student, is through commitment. Commitment to studying, commitment to putting in the extra hours in your books. I know it's not going to be easy. Actually, no one said it will be easy. But if you keep pushing and if you keep believing a little more in yourself, then the results will show in your life. Commit and become. The road to success is to commit.
Just 2 minutes to copy the homework. If you can, try to be fast. Diagram fast for 2 minutes. Write the questions. Maybe someone can write the questions, someone draws the diagram, and then later you can combine your two things. Okay, work with your friend there. Just try for 2 minutes. Welcome back, Cretans. Let's summarize our lesson. We didn't interact today. Cretans, please, next week, let's engage each other, okay? Right. And then, what did we learn today? The midpoint theorem states that the line segment joining the midpoints of two sides of a triangle is parallel to the third side and equal to half the length of the third side. And then the line drawn from the midpoint of one side of a triangle parallel to another side will bisect the third side. Thank you very much, Cretans. We're going to meet next week, and please don't miss the lesson. Goodbye and enjoy the rest of your day.